Alright, good day guys, how are you all doing? We're discussing, we're talking about the homogeneous equation under the first order differential equation. Now, what you, if you haven't go through my video, that's under the variable separation of first order differential equation, please go back to it before you move into this, so as to have a deep understanding. Now, you see, we can make some certain type of equation that they are not in the variable separation them. We can make it to become variable separation by changing the variable. Variable separation, changing the variable. So equation like this form now, we are dealing with a first order differential equation. So of course, this kind of form, p dy dx equals to q. Now if p and q are of the same degree throughout, we say that that kind of what? That kind of particular equation is homogeneous in terms of the y and x variable. Now, that's the function of x and y. It deals with the function of x and y. Now, the function of x and y being equals to x squared plus 3xy plus y squared is an homogeneous equation. Why? Is that if you look at the degree of x here is 2, degree of y here is 2, degree of y here is 1, degree of x here is 1. So which means that all of them have the similar term. They have an homogeneous term. 2 1 2 1 doesn't surpass that. So at that point we say it's an homogeneous function since each of the term has equal degree. Now what is the procedure to solve the differential equation of this kind of form? The first thing is that you have to rearrange the function or rearrange the particular expression in order to have an equation of dy dx being equals to q over p. I don't know how you want to do it. You have to find a way to just do it and have only dy dx. Now at that point you make a substitution, y and x, where v is a function of x. So the first thing you have to say is that y equals to what? Vx. And if you look at now, since you have v and x, what do you need to apply? You can apply a product rule whereby u is equals to v and v is equals to x. So differentiating u with respect to x, since v depends on x, you can evaluate v. Are you with me? So du dx would be du dx du dv rather. You have du dv being equals to 1, and at that point you have v being equals to what? X. So you have the v with respect to dx. Now, if you look at this point, looking at this question here, you were having the v with respect to ds. How is that possible? Not that it is not being differentiated, but just like you differentiating, what do they call it? The function of v in terms of relation to the x, the v dx. Now, the next thing is that you have to substitute. And when you talk about substitution, what do we mean? If you substitute y and what? The y over the x, you substitute what you get in both of them into that equation back. So after you substitute them into that equation back, then what do you now do? You simplify by cancelling what? And what? All the equation, you balance it to simplify it. So the result you get while you are breaking it down or you simplify it will result in a variable separation, which way by what? You can now start solving it. How you get what I'm saying? So let's go to the 2 steps that we have left, and literally this is like the important steps, so you can note it or jot it somewhere. Right, so from the part we do what? From the fourth is that we separate the variable and we solve the variable with the equation with the variable separation method. And I felt like I've given you guys the 3 categories of the first order variable separation method. If you don't know that, please go back to my video and go and check it out, variable separation. Now the fifth thing is that we now substitute in the last part v equals to y over x to solve the equation in terms of its original variable which was there before. So if you have to look at this particular question now, y minus x equals to this. This you would have, you have the general solution for a particular differential equation, and also the breaking down or the direct final solution. So this is now a normal equation where you won't have a constant because we are going to be getting the value of the constant c. Now at this point we use the first step. We want to find our dy over dx. So your dy over dx at this point you have y minus x over what? Over x. Right? And from the second step we said let y equals to vx. And let our dy over dx be equals to v plus x, the v over dx. If you have to sub that into here, you are going to be having v plus x, the v over dx. Are you with me? Equals to y now becomes what? Vx minus x over what? Over x. Are we there? So at that point you have v plus what? The v over dx being equals to what? Vx minus x. you can substitute, you can factorize this. You have x into bracket v minus 1 over x. So this cancels out. Then you have the v over the x being equals to v minus 1 minus v. Are you with me? So this x, do not forget your x. So at this point, please hope you are following the steps. You have v plus x dx, v plus x. Then you move the v to the side here. So at this point, you have x, the v over dx being equals to what? Negative 1. Are you with me? So negative 1. This cancel out this. And if you have to look at now, you literally say that it's the variable of x. That means the function of x that we are literally dealing with here. So it's like a direct there. You make this come to this other side. So at that point, you have the v over dx being equals to, if you have to, what do they call it? You have to divide both sides with x. You have over x, you have over x, you have negative 1 over what? Over x. Are you with me? And at this point, we were able to break it down already. So what we need to do is that we need to now apply the normal variable separation method to solve our problem. And before that, at this point, you are going to be having the v equals to what? Negative dx over x. Are you with me? So then, moving on literally, what do we have to do next? We integrate the part. So integrating the v equals to negative integrating dx over x. Are you with me? Putting the negative value outside. So you have v being equals to negative dx over x. You have what? In x plus what? Plus c. Are you with me? And at that point, we need to evaluate our constant value. But before that, the question tells us that this is like at x equals to 1 and y equals to 2. But before that, we do our final dem by doing what? We substitute it back to its original equation. So we are going to be having v being equals to what? Y over x equals to negative in x plus c. This dem, you've getting your answer at this point. With if you are not to associate this to it, this we call this one a general solution. So any other ones that you are doing in order to break it down much more, those ones are just to get the final main solution. But this is a general solution that is also acceptable. So but literally we are being given boundaries. So we have to evaluate our boundaries to find our constants. At that point, if you have you have 2 over 1 equals to negative in 1 plus c. This will give us 0. So you have your constant c being equals to 2. So at that point, since our constant c is equals to 2, from the normal general equation back, which is y over x equals to negative in x plus c. Are you with me? That means our value would be y over x equals to negative in x plus what? Plus 2. So by breaking it down, you can have y being equals to negative x in x plus 2x. So this should be your answer to a certain particular equation. So